For this question, it says graph and label the image of figure ABCD under a dilation centered at the origin with a scale factor of 2. We're going to find the x and y coordinates for each of our points. So we have A, B, C, and D. And then after that, we are going to multiply by a scale factor of 2. So A is 0, 0. B is 2, 3. X is 2, y is 3. C is 4, 3. D is 4, 0. So to get our new points, what we're going to do is we're going to multiply by 2 to each of the first points, and we're going to get the prime or the copy of the first point. So for A, we get 0, 0 because 0 times anything is 0.
B prime, we get 4 and 6.
For C prime, we get 8 and 6. And for D prime, we get 8 and 0. So what we'll do is we will go ahead and graph these points. We will draw our new figure, and that is it for that problem. So this is what that looks like dilated. And then I'm going to go ahead and label everything A prime, B prime, C prime, and D prime. There's one important thing to remember from this question. It is this equation right here, that the copy equals the scale factor times the original. So copy equals scale factor times original. Put that into your memory.
For this question, figure PQRS prime is the image of figure PQRS under a dilation with center P and scale factor of 1/4. Indicate whether each statement is true or false. So as we look at this, we see the original image, PQRS, and we see the measurements of the angles and the measurements of the two sides. And these sides are parallel, indicated by the lines. And so let's look at each question and answer them individually. It says the measure of angle S prime, so the copy of angle S is 72 degrees. Now that is true because if we do scale something, whether we make it bigger or smaller, the angle is going to stay the same. So if that's true, we'll go ahead and mark that, and then we'll look at the next one. The measure of angle P prime is 27 degrees. Now, 27 degrees is 1/4 of 108. However, we did indicate that the angle measurements will not change, and so it's actually P prime is going to be 108 degrees. So we can mark this next one false. This one says that PQ is parallel, PQ prime is parallel to SR prime. Now look at PQ and SR in the original. They are actually parallel to each other. So therefore, the image of this, PQRS prime, will also be PQ prime and SR prime will also be parallel to each other, so that is true. Next it says the length of PS prime is 8 centimeters. Now, if we scale something by a scale factor of 1/4, what that means is that we're going to take 8 and we're going to divide it by 4. So if we divide 8 by 4, then we cannot have the copy of PS also be 8 centimeters. It's going to be 1/4 of that. So this would be false, which means that our next one, the length of QR, QR prime, which QR is currently 8. So if we take 1/4 of QR, we will get 2 centimeters. So that makes this statement true. So we learned in a previous lesson that if we have right triangles with horizontal and vertical legs, where the hypotenuses lie on the same line, that they are similar. So that's going to help us answer this question. It has two triangles, ABC and DEF, and it has some fill in the blanks here. It says ABC and DEF are similar, congruent, or neither congruent or similar. Now, if you look at them, you can tell that they are not congruent. Congruent would mean they're the same size. So they actually are similar, which allows us to go through the entire statement. It says ABC and DEF are similar, so the lengths of the corresponding sides of the two triangles are either proportional, equal, or neither equal or proportional. Now, equal would mean that they are exactly the same, and since we know they're not congruent, it can't be equal. So we're going to eliminate equal. And then proportional just means that they change at the same rate. Now, if you take a look at the scale factor of these do in fact change at the same rate. One is 1 over 3 for the scale factor, or for the height to base ratio, and the other is 2 over 6, which actually gets us into our last question, which says that the ratio of the triangles, of the height to base ratio of triangle ABC and triangle DEF are either equivalent to, greater than, or less than the height to base ratio of triangle DEF. So they are actually equivalent to, because like I mentioned before, we have 1 over 3 and we have 2 over 6. 1 over 3 is in fact equal to or equivalent to 2 over 6.
All right, for this problem, it says indicate whether each equation has only one solution, infinitely many solutions, or no solution. So what we're going to do is we're basically going to solve each of these equations. We start with distributing if need be. So we're going to go ahead and distribute 6 over x and 6 over plus 2. We are going to get 6x plus 12 equals 6x plus 12 for the first one. Now here's what you should notice. The linear terms are the same and the constants are also the same. So linear term is 6x, which means we can put in anything for x and we will get the same answer on both sides. So for this one, there are infinitely many solutions. For the second one, we're going to go ahead and distribute 3x plus 4 equals 3x minus 12. Now what you notice, or should notice, is that the linear terms are the same, but the constants are not the same. So when we cancel out the linear terms, we're left with 4 equals negative 12. 4 can never equal negative 12. Therefore, for this one, there are no solutions. For the next one, we're going to go ahead and combine like terms. So 3x and 4x is 7x minus 5, and then equals minus 4x plus 6. Now for this one, I don't have to solve it. I can see right away there will only be one solution because the linear terms are not the same and the constants are also not the same. But if I did solve it, just to prove a point and to show you here, if I get rid of the x's from one side, so 4x from one side, I go ahead and add it to the other side. I have 11x minus 5 equals positive 6. Next, I'm going to go ahead and add 5 to both sides. I'm going to be left with 11x equals 11. And then if I divide both sides by 11, I will get x equals 1. So there's actually just one solution for this. Remember, there's one solution if the linear terms are different and the constants are also different. Now for this last one, we're going to go ahead and distribute. So 5x plus 10 equals 7x plus 12. I'm not going to solve this one, but you should see that the linear terms are the same and the constants are different. Linear terms are different. The constants are different. Therefore, there is one solution. So to recap, if the linear terms are the same and the constants are the same, there are infinitely many solutions. If the linear terms are the same and the constants are different, there are no solutions. And if the linear terms are different and the constants are different, there is one solution. Now this question asks, what is the value of the ratio of y over x? Now what we do have are two right triangles that have horizontal and vertical legs, and the hypotenuses lie on the same line. So again, we do know that they are similar because of that. Now let's look at y over x. So y over x is the height to base ratio, and we want to figure this out by comparing y to the corresponding position on the other triangle. So I highlighted them in yellow. We have y and we have 7 in corresponding positions. So that becomes our height, and our base is going to be x, which is 16. And so simply put, our answer is 7 over 16, and we can actually leave that as it is because it cannot be reduced. So that is our answer. Now again, we just want to make sure that we are looking at the height to base ratio, or the rise to run, as you've learned to call it as well.